In this section, we'll take a look at one-to-one functions and inverse functions. Here's the definition for a one-to-one function. A function is one-to-one if every horizontal line intersects the graph of the function at most once. This is the definition for what's called a horizontal line test. So let's take a look at some of algebra's common graphs to see if they are one-to-one, that is, if they pass a horizontal line test. First, we'll take a look at a linear function. And for our linear function, the most general form is y is equal to x. So if we take a look at the function y is equal to x on a graph, and here's a basic sketch of a linear function, we'll notice that if we apply a horizontal line test, which is a horizontal line, and we notice that there's no more than one point of intersection, this function would pass a horizontal line test. So any linear function is one-to-one. Let's take a look at a quadratic function. The most general form of a quadratic function is y is equal to x squared. And if we take a look at this most general function on an x and y axis chart, we'll notice that it will form a U-shape or a parabola. If we were to apply a horizontal line test, notice that we have 2 points of intersection. So for any quadratic function, these are not one-to-one functions. Let's take a look at a cubic graph. The most basic form of a cubic equation is y is equal to x cubed. And if we take a look at a cubic equation on an x and a y chart, we'll notice that it should form an S-shaped graph. If we were to apply the horizontal line test to this S-shaped graph, notice that it would in fact pass a horizontal line test. So any cubic function is one-to-one. We'll take a look at another one of algebra's common graphs, the absolute value function. And an absolute value function is in the form y is equal to the absolute value of x. If we were to graph the absolute value function in an x and y axis, we notice that it forms a V shape. If we were to apply a horizontal line test, notice that it intersects the graph at more than one point. So every absolute value is not one-to-one. Now we'll take a look at an inverse function. And here's a definition of an inverse function. Addition and subtraction are inverse operations, as are multiplication and division. You start with a number, x, multiply by 8, and then divide by 8 gives x back as a result. Therefore, the functions f of x equal to 8x and g of x equal to 8 divided by x are inverses of each other. Here are the steps to find the inverse of an algebraic function. For a one-to-one function, f is defined by the equation y is equal to f of x. Find the defining equation of the inverse as follows. First, we interchange x and y, which means wherever we see an x, we replace that x with a y, and wherever we see a y, we replace that y with an x. We solve for y, and then we replace y with the f inverse symbol. This f raised to the negative first power of x is not read as f to the negative first power. This is read as f inverse of x. So let's take a look at an example. Here we're asked to determine whether the given function is one-to-one. Here we're given a relation, and a relation is just a set of ordered pairs. So we're given this relation 1, 0, negative 6, 2, negative 2, 0, and 0, negative 3. In order to determine if this relation is a function, we'll use what's called a mapping, where we'll map the domain onto the range. So here I'll make two columns. In my first column I'll have the domain values, and in the second column I'll have my range values. The domain values would be all of the x coordinates. So my domain would be 1, negative 6, negative 2, and 0. My range values would be all of the y coordinates. So I would have 0, I would have 2. There's another 0, so no need to list that twice. And I also have negative 3. Since we're doing a mapping, every element of the domain must correspond exactly to only one element of the range. So now we'll map out our relation. So 1 maps to 0. It maps to exactly one element in the range. Negative 6 maps to 2. Negative 6 maps to only one element in the range. 2 maps to 0. Negative 2 corresponds to exactly one element in the range. 0 maps to 3. 0 corresponds to exactly one element in the range. Therefore, this relation is a function. Let's take a look at another example. Determine whether the given relation is one-to-one. So here we have the relation f is equal to 1, 1, 2, 0, 1, 4, 4, 3. And as in the last example, we will map out this relation. So we'll put our domain values in one column, our range values in another column. So recall that the domain values are all of the x coordinates. So our domain is 1, 2, there's another 1, no need to list it twice, and we have 4. Our range values are 1, 0, 4, and 3. And now we'll map the domain onto the range. 1 corresponds to 1, exactly 1 element in the range. 2 corresponds to 0. 2 corresponds to exactly 1 element in the range. 1 corresponds to 4. And here we have a violation of the definition of a one-to-one function. Every element in a domain should only correspond to exactly 1 element in a range. Notice that 1 corresponds to 2 elements in the range. 4 corresponds to 3, so 4 corresponds to exactly 1 element in the range. Since we have a violation of the definition at 1, this relation is not a function. Now let's see how we can take an equation and find the inverse of an equation. Here we're asked to find the inverse. And we're given the equation f of x is equal to x squared minus 7 with the condition that x is greater than or equal to 0. So notice earlier we said that every quadratic equation is not an inverse function. However, in this particular equation, we've restricted the domain to all values x that are greater than or equal to 0. So this equation with this restriction on the domain would pass a horizontal line test. So the first thing I'll do is I'll rewrite y as f of x. I'll take it out of function notation. So I'll write it as y is equal to x squared minus 7. Next, I'll interchange x and y. So wherever I see a y, I'll interchange that with x. And wherever I see an x, I'll interchange that with y. So now I have x is equal to y squared minus 7. Now I'll simply solve it for y. So I'll add 7 to both sides. I'll use the square root property. Y is equal to the square root of x plus 7. And now I'll change y to the f inverse symbol. So f inverse of x is equal to the square root of x plus 7. Thanks for watching.